Okay, so we're going to now start to build some real foundations for chemistry. And we're going to come into chapter 3 and we're going to talk about matter and energy. All right, so first of all, we're going to classify matter. We're going to talk about how matter can be described. All right, so matter is, let me go here, get my marker out. Matter is a material that makes up all things, okay? And it's anything that has mass and occupies space. So basically, matter is not love, it's not liberty, it's not hope, but it's just about everything else, right? So our learning goal here for this chapter is to classify examples, for this section, is to classify examples of matter as pure substances or mixtures, and what kinds of mixtures. That's our learning goal. So first of all, pure substances have a fixed or definite composition. All right, they have a fixed or definite composition. And we're going to play this out just a little more in the next couple of slides. Mixtures now are not pure substances, right? They contain two or more different substances that are physically mixed but not chemically combined. They're physically mixed but not chemically combined. Those are mixtures, okay? So a pure substance is classified as a type of matter with a fixed or definite composition, or it's an element that is composed of one type of atom, or it's a compound that is composed, I guess I really didn't have to say or there, this sort of, where's my vocabulary? Forget it. I'm just going to put an X through here and say we really are interested in elements and compounds. I will think of the word I was looking for later for that and come back and say it. All right, so an element that is composed of one type of atom, or it's a compound that is composed of two or more elements and always combined in the same proportion. Those are what pure substances are, okay? So an aluminum can, for example, consists of many aluminum atoms. So there's like a little aluminum atom. Of course, aluminum atoms are not little gray spheres, but it might be a good way to think of it, that it's a little matrix or a little three-dimensional array of aluminum atoms. That's what an aluminum can is made of. Okay, elements now, to give more examples, are pure substances that contain only one type of material and cannot be broken down into anything smaller until you get the protons and neutrons and electrons apart. Okay, so an example of a compound is copper, lead, aluminum, carbon, fluorine, nitrogen. These are elements, okay? And you find elements, this is our little flowchart which we're going to make. It's a pure substance, okay? It is matter. It's a pure substance, and elements are just substances that have only one type of atom in them. All right? Compounds, however, have more than one type of atom in them. And a compound contains two or more elements in a definite ratio, such as hydrogen peroxide, which is H2O2. It's got 2 atoms of hydrogen for every 2 atoms of oxygen. Table salt, which has got 1 atom of sodium for every 1 atom of chlorine, right? Table sugar, which is made of which is sucrose. It's got 12 carbon atoms for every 22 hydrogen atoms for every 11 oxygen atoms, right? And then water, right? So those are compounds. Again, they contain 2 or more elements in a definite ratio. The ratio here is 2 to 1. The ratio here is 12 to 22 to 11. The ratio here is 2 to 2, okay? So those are compounds. Now, elements in a compound, we already said this, okay? So an example of a compound might be sodium chloride, and there are elements in the compound's made of 2 or more elements, all right? That's what that comes from. Let's move on. Mixtures now is a type of matter that consists of 2 or more substances that are physically mixed but not chemically combined, okay? And we'll get used to looking at these. 2 or more substances in different proportions, okay? So they don't have to always be in the same proportion if it's a mixture. Substances that can be separated by physical methods. So if you can filter something out, it's a mixture, right? You see this chemist's hand here is pouring something through there, liquid's coming out, a solid staying up here. If you can separate them by filtration, by some physical method, then you have a mixture. Now, there are 2 kinds of mixtures. There are homogeneous mixtures, and that is homogeneous mixtures are uniform throughout, okay? So, for example, brass is a mixture of carbon and zinc atoms, where carbon might be the little black things, and this is that's a little piece of, I guess, a doorknob, okay, piece of brass. And you've got a bunch of copper and zinc mixed in, all right? It's not a definite proportion necessarily, but it's uniform throughout. No matter where you go in that piece of brass, it all looks the same, okay? The different parts of the mixture are not visible. But there's also heterogeneous mixtures, and heterogeneous mixtures are things like metal and water mixed together, okay? Or sand mixed with water, right? Where there's water right there, and you've got sand right here, or that's copper, I guess, okay? So heterogeneous mixtures, they vary from one part of the mixture to another. So if you take 1 teaspoon of sandy water, and then you take another teaspoon of sandy water, you might not have the same kind of sand in each teaspoon, right? And it turns out that in heterogeneous mixtures, the different parts of mixture are visible, okay? So that's the classification of matter. Let's just go back over this again, and then we'll do a learning check. All right, so first of all, you have matter, and you either have mixtures or you have, mixtures over here or pure substances. Pure substances are either elements or compounds, and mixtures are either homogeneous, where they're the same all the way through, or heterogeneous, where you have sort of, and you can tell. When you've got a heterogeneous mixture, you can tell by looking at it. Brass, it's a little bit difficult to see with your naked eye that brass, for example, is not a compound. It almost looks like it could be, the same as that when you're looking at it with the naked eye, right? So that's going to be, I think, a little difficult is to see what's a heterogeneous mixture. A homogeneous mixture. But compounds and elements, right, there's going to be some, definitely going to be some easy things here. So let's look at a learning check. I'm going to show this learning check. I encourage you to pause the video, come up with an answer, and then come back on and see what I say. Okay, so let me suppose you paused it. This is definitely a mixture. Pasta and tomato sauce. You can tell by looking at it, right? It's not just a mixture, it's a heterogeneous mixture, right? Aluminum foil is definitely not a mixture. That is a pure substance. Pure substance. Helium is a pure substance. And air, I think, this is a difficult one. I think we should say that that is a pure substance. Unless you look big enough at the big enough sample of air, then you might see a cloud, in which case you'd say, all right, if I see a cloud someplace, or fog, or smog, or whatever, then it's definitely going to be a mixture, right? So I think air is a difficult one. It depends if you're looking at a small sample of it, like the air inside a balloon, that's definitely going to be a pure substance. But if you're looking at the, actually, no, that's not going to be a pure substance, right? That's going to be a mixture, sorry, because air inside a balloon is going to have some water molecules in it. No, it's definitely a mixture. It's going to have some water molecules in it. You might not know that, right? It's going to have some O2 in it. It's going to have some N2 in it. It's likely going to have some argon in it, right? So all these things are components of air, so it's definitely a mixture. Okay? All right, let's do another one, and then we'll be done. Pause the video, and then make your answers, and then come back. Okay, so let me suppose that you paused the video, and I'm going to say that this is definitely heterogeneous, right? Got a banana, you got fudge, you got ice cream. That's definitely heterogeneous. Shampoo, I think it depends. If you see little flakes in it, right, or streaks of stuff in it, then it's heterogeneous. But I think most shampoo is homogeneous, okay? That is, no matter what sample you take, it's going to look the same. Sugar water is definitely homogeneous, right? That is, unless it's got sugar flakes at the bottom, right? But let's suppose it's just plain sweet water. It's going to be homogeneous. What about peach pie? All right, that's definitely heterogeneous, right? You got peaches, and you got syrup, and you've got crust, and whatever else, okay? All right, so hope that's helpful. We'll practice these throughout the semester. I wouldn't say a whole lot is built on this, but it is important for us to be able to start from the ground up with what is matter.